Hello everyone, how are you? Good. So today our topic of discussion is building real-time AI voice apps with Azure OpenAI GPT Real-Time API. Okay, and we have a speaker, Mohammed Elrasheed. He's a solution engineer at Microsoft, and I know a lot of you guys, right? So we don't need much discussion about that. But we have Fateh, who is also a Microsoft employee. We have Nuran, from after a long time, right? And myself, I am Hamza, and I am a MLSA, Microsoft Learn Student Ambassador. That's it. Let's start this discussion.
Okay, thank you so much, Hamza. Hello, everyone. My name is Mohammed Elrasheed, and today we're going to talk about building real-time AI voice apps with Azure OpenAI. Did anyone build something with Azure OpenAI real-time? Great. We have some people. What about the text APIs, the normal chat completions, the normal LLM integration? Okay, perfect. So, 2 point. Did anyone build something with Azure?
Okay.
Let me just. Actually, it worked. I did a quick test. For some reason, it doesn't. Can you switch it up?
So let me bring this.
Okay.
Right, it's fun. I will bring mine also.
Okay. So today we're going to discuss 5 topics: why we need GPT real-time and its use cases, how GPT real-time works, and we're going to discuss the HTTP versus WebSocket protocol. Did anyone hear about the WebSocket protocol? Okay, perfect. And then we will do a quick walkthrough on the service in Azure portal. Then we will have a look at an actual demo, couple of code snippets, how to use it, and we will finalize with the architecture typically we use for telecom integration. Do you have any questions? Perfect, let's start. So traditionally, when people wanted to build conversational experiences where you chat, speak with AI, not through text, but through voice, they used to do a couple of steps. So they do a step called STT, speech to text, which means that we receive the voice from the customer, we convert it to text. Next, they use LLM inference. So that converted text gets sent to LLM model, something like GPT-4. Once the response is returned, that returned text is converted to speech. And in the middle, if you have tool calls, that gets executed as well. And of course, you can see the challenges with this approach. Can anyone tell me what challenge do you see with this approach? Yes, that's a very important point. One more point. Yes, what does that mean? A lot of engineering. Yeah, so it requires a lot of engineering. And also it means that you need to maintain the context across different services. So engineering-wise, latency-wise, it's challenging actually to maintain. And in general, we see around 4 to 3 seconds before hearing a reply back. So these are the problems in a nutshell. Number one, the latency, as you rightfully said, the complexity of the integration, and the fact that this pipeline is fragmented, which means that if you want to maintain the conversation context, you need to find some integration to connect the three services, the speech-to-text, LLM, and text-to-speech. So in order to address this challenge, OpenAI released a service called GPT Real-Time. That service was released in last August, I believe, and went through a couple of iterations until it became a GA. The whole idea of that service, you don't need to worry about stitching speech-to-text, text-to-speech, and text-to-speech, speech to LLM, and then speech-to-text. You will just speak with AI. The AI will do the magic. You will get the voice back. So from here, you get a couple of benefits. So number one, you need to care only about one AI model. You don't need to care about 3 AI models. You get continuous bidirectional streaming, which means lower latency. And the integration is simpler using an event-driven API that follows WebSocket. We're going to look at that in a moment. So, and that model supports 3 things. Supports the speech as I've just described. You can use it as a text model as well. So you can chat with that model with text and receive responses. And it supports tools calls as well. So if you want to use it for agentic AI use cases. So some of the common AI use cases we see, number one, in the banking system. So customers can use it to authenticate, to ask about their balances, and so on. And the AI-enabled assistants. So does anyone use, is anyone using ChatGPT or Copilot app on the mobile? Perfect. Have you tried the conversational experience? Perfect. That's built on GPT Real-Time, actually. Same thing in telecom industry, we see it being used in IVR systems. So instead of, clicking on 1, 2, 3, you can just talk to it. So when to think about this GPT real-time is when you want a low latency in the conversational scenarios, you want to enable bargain experience. So one of the amazing experiences we see with GPT real-time, as we're going to see later on the demos, is that you can interrupt it. So if it speaks, you feel that it goes out of context, you can just interrupt it to bring it to the topic that you want, okay? And there are, of course, other scenarios where the normal LLMs, conversational text LLMs, work better when it's just a simple chat or you want to do, patch offline processing that you can't do in real-time manner and so on. So now we understood why we need GPT real-time, its use cases. We're going to go slightly more technical here to understand how it works and some of the details behind it. So when you implement a GPT real-time, you generally have this high-level architecture. It's not a detailed architecture, but a high-level architecture, I would say. You have your client app, could be web app, mobile app, whatsoever. And I'll come to this. You have the GPT real-time service that could integrate your knowledge and data or tools. And in the middle, typically, you write a backend service. That service will be responsible for taking the audio configurations from the user and then interacting with the GPT real-time, okay? The interaction here and here goes through WebSocket connection. We're going to look at that in a moment. But the question here, why do we need this layer in the middle? Why don't we integrate directly from the client app to the GPT real-time? Any ideas?
Maintain sessions.
Yes, but we can maintain that session directly as well, right? Very good point, security. But why it's more secure to have it here, not here? It is indeed isolation, but if you can give more details. Sorry? Yes, okay, but what kind of filtration here?
You mentioned a while ago security, so it might be hacking or unauthorized like access or something like this.
Yeah, very good point. But one more question, why it's more secure here, but not here? Yeah.
So first of all, it's separation of concern. For example, middle layer might need to connect with our database as well, based on the query, right?
Yes.
So instead of giving access to the real data direct from the client side, it is always better to have a different layer for this. Second thing is the independent scaling for both the instances. So in future, let's say our middle tier is taking more time, we can scale up the middle tier only.
Yes, very good. You are an architect, right?
Yes.
That's an architect answer. Well done. Yeah, and the core thing here also, this runs on the backend, right? So this does not run in the user browser. The user or the customer does not have access to this. The customer accesses this, right? This is runs on their mobile app or their web browser or so. Yeah, so that will act as the point that will needs to maintain the session running on the backend. Okay. So the interaction flow typically goes as the following. You have the user, the middle layer, GPT real-time, and any tools that you use. As you interact and speak with a service, at the same time, your audio from the middle layer gets forwarded to the GPT real-time. And as you speak, the inference takes place. And as soon as the reasoning identifies that there is a need for tool call, that happens. And that's the main differentiator of GPT real-time. Instead of the older setup where you need to do speech to text, LLM, text to speech, you manage to overlap those three different actions together. There you get a lower latency. Do you see how it works? Cool. Yeah.
That means the real-time GPT it's a black box. I understand that it's speech-to-speech conversion, but at the back end, does it convert the speech to text? Or
Of course, they do that on the back end, but they do it in a smart way. Like as they convert, as they reason and start using the tools, and they don't need to wait for the whole text to come and start the conversion. So as the text comes, it gets converted. Okay.
Usually there is the making sure that the user is not asking questions that the LLM is not qualified to answer on. So this happens in this middle tier, or how does that happen in real time?
Very good point. So we call this guardrails. You can protect that in two different ways, either through something called system prompt. We can have a look at that actually. Remind me to apply that in the demo, okay? To affect the behavior, or something called guardrail. We are not discussing guardrails here, but the idea is that you can apply certain controls on the input of the model and the output of the model. We support that in Microsoft Foundry. So as we've just discussed, so the middle tier, it keeps the credential on the server. It enables the server on session. We're going to have a look at that, the server configuration and server session, all that goes with the WebSocket discussion. And it's a single place for everything in order to connect to the database and all different services and to isolate it from the consumer. So when you want to interact with the GPT real-time service, there are three ways you can use it. First way is to use a protocol called WebRTC. Anyone familiar with that protocol? Okay, perfect. Everyone here has used this protocol, and I can swear by that. So when you have a video chat, or a video conversation, that goes through WebRTC. Yeah, you use it every day, of course. So the thing about WebRTC is that it does not need a server in the middle. It does some architecture magic so that eventually the connection goes directly from user to user. It doesn't go through a server. You have a WebSocket protocol. We're going to explain it in a moment. And then there is something called SIP. SIP is something coming from the communication word. It's an abbreviation for Session Initiation Protocol. In this session, we're going to discuss WebSocket. We are not going to discuss the WebRTC integration or the native SIP integration in the main part of the session. At the end of the session, we're going to bring up the SIP just to show how to integrate with the telecom industry. But the whole focus here will be on the WebSocket, okay? Okay. How the WebSocket protocol works. In your daily work, you are mostly working with HTTP. So for example, if you go to www.msn.com, what happens is that you send an HTTP request, usually HTTP request called a GET request. The server processes that request, returns it. And here the server opens the connection. Once it serves back the request, it closes the connection. The connection behind the scenes, it's a TCP connection, okay? This works well if it's a single action or a single event. But when we are talking about something like audio, where you have a stream of events, this does not work. This does not give a smooth audio experience. That's why we use a different protocol called the WebSocket. The idea of the WebSocket protocol is very simple. Instead of opening a connection, closing it with every single request or every single event, I open a connection once and maintain what's so-called a channel. That channel will remain maintained for as long as the user session. And within that session, I send a series of events. This way, I get rid of the TCP connection establishment and TCP connection closure. And this works well for the voice real cases, okay? So just to compare, HTTP is good if you want to load a page, if you are calling a REST API, downloading a file, and so. WebSocket is good for live chats. So most of the live chats, by the way, you see, they follow the WebSocket connections. Multiplayer games, stock crypto tickers. So if you want to get a real-time update on the prices and so. Sports scores, collaborative documents, even though sometimes documents use WebRTC, real-time voice and video. Actually, this is only voice, not video. Okay. So now I will navigate to Azure portal just to see how to deploy the service, how to use it. We're going to look at the underlying WebSocket events. You will learn how to look at them and inspect them in the browser before we go to the subsequent steps. Up to now, any questions on those 2 points? All clear? Okay. So this is my Azure portal. And here I have deployed a resource, Microsoft Foundry, as you know. And I'll log to my Foundry. So the way I deploy this model, simply I go on the left, models and endpoints. I am using the old Foundry experience because there is a playground feature I want to use. That playground feature does not exist yet on the new Foundry experience. I go here, deploy a base model. And then I can look for the GPT real-time model, okay? So I have already deployed it, so I don't need to do that again. And let me pick this one. Open it on the playground. So before I start interacting with the model, I want to enable something on my computer. So this is the audio playground. Here, you can see the model, the system prompt I have for the model, voice configuration. And here I'm opening the network tab on the browser just to inspect the underlying HTTP request, and you actually see what's happening on the wire. So let's start by doing something simple.
Specific on your mind, just say the word. Say the word. Aha, I see what you did there. You said the words.
An echo. Sorry. Remove this. No, it's not. Okay. So I ran it. Let me mute this. So if I look at the request over here, you will see that there is a request to this endpoint. So this endpoint is the WebSocket endpoint for the GPT real-time. It will have my Foundry resource base URL, the GPT real-time name, and the API key. Okay, now I need to rotate that API key. The WebSocket connection gets established at the beginning as a normal HTTP request with the status code 101 switching protocols. Then if the server supports the WebSocket, it will respond with the WebSocket. Okay, this is how the protocol works. I highly recommend you have a look at the RFC of that protocol and understand it, how it works. So as we interact with the GPT real-time, we receive a series of events. Those events could be incoming or outgoing events. So you see here, for example, this is an event we received from the server called response done. And in each event, there is a certain payload. And the key thing to notice here is that at the very beginning of the WebSocket connection, let me show you a couple of interesting events. So when I start the WebSocket connection, you will see that, let me just expand everything. So you will see that there is an event named session update. This event is being sent on the WebSocket connection at the very beginning of the connection in order to configure your GPT real-time model. And there you can see there is a certain JSON payload that tells, okay, what type of sampling I want to apply, what type of audio format I want to use, the transcription model. So the GPT real-time provides you with a transcription as well. And here you can control what model behind the scenes it should use to transcribe your conversation. And a certain configuration called the server voice activity detection. And this has to do with when the customer or when the user speaks with the server. What's the silence duration? The silence duration is for how long the customer should stay silent so that the AI considers it, okay, it's time to reply, okay? Prefix padding. So this is as well what would be the prefix in milliseconds that the AI will put before the response to be sent back, okay? It's very detailed configuration. I will share with you a URL for the talks in order to understand the different configurations you can set up, but it's highly controllable. The last piece here, of course, is the system prompt. So if I go here, you see, this is the system prompt that we usually used to have in the normal LLMs. We send it here as well. So here you can control the personality of the AI. The cool thing, that means after you establish the WebSocket, if you want to change the personality of the AI or you want to change the instructions, you just send another event. Does that make sense? Do you understand how this eventing architecture works? Perfect. The last thing to discuss in that eventing part is that there is an event called input audio buffer. So that event simply represents the audio chunks. So as you speak, your voice will be converted to this format. I think it's base 44 or something. That's the binary representation of that specific audio chunk, and it will keep being sent. So as you speak, like every millisecond or couple of milliseconds, it will keep sending voice events. And this is what enables the latency, the low latency in the WebSocket protocol. The same thing, there are similar events that come from the server. This has to do with the transcript, but the idea is the same. So as the transcript comes, it will keep sending an event from the server. So that event, for example, is here can. That means within that specific event, we received can word, and so on. So I think there are more than 30 or 40 events, both client side and server side event. Some of them has to do with tool calling and so. We won't go through all of them, but just I wanted to give you a bit of a mental model how that works. So go ahead.
Yeah. Saying that basically every millisecond we throw a chunk back at the LLM.
Yeah, don't quote me for millisecond, but it's every couple of yeah.
So to be running this continuously on real time, is it using like multi-threading or is it just using like a single path where it goes back and processes again and goes back and processes again?
A very good question. So per customer, you generally implement a single thread. So if you want to scale this design generally, this is where you start a multi-thread. So if you look at the code samples, that has to do with this for multiple customers running on parallel. For every new customer, you shoot a thread. So that separate thread will be responsible of maintaining the session for that customer. But for a single customer, for this use case, a single thread is enough. Because as you speak, this is very fast. As you speak, this immediately gets picked and sent through the WebSocket channel. Does that clarify it?
Yes.
Okay.
So I'm assuming that there's a maximum number of concurrent users using this at the same time until more users get queued, basically, right?
You mean on the GPT Real-Time service?
Yeah.
I'm not aware if there is a specific number on that, but of course there is. But the good thing, this is considered as a SaaS service. So it's hosted by Azure OpenAI, and they will take care of scaling up requirement. But of course, like if you start a billion session, I would expect the service will go down. See, sorry?
How do you open that thing?
Okay. I'll show it here so that everyone can see it. So that view I have opened is called developer tools. So if you go here in the browser and click on, no, then, okay. If you right click on the browser and click inspect and go to the network tab, you will have this view. Okay. Yeah.
This chunking where it's you say cycles, is it redefined so we can change this as well?
So very good question. This is something is controlled on the client side. Okay, as a client, you control it. How often you want to do that? There is a certain number like that you should not go beyond, so that for the human ear, the voice does not appear, as tick, tick. I don't know that number, frankly speaking, but this is how it generally works. It's like the video, right? So what's a video? A video is a chunk of image, right? It's the same thing. This smooth voice is a small chunk of elements, but you send it fast enough so that the human ear does not distinguish it. Okay. Yeah.
Just hang on. People at the back can hear you as well.
I wanted to ask if we have a background noise, let's suppose, or a nuisance. So, how does the bot distinguish between the client or the customer voice and the background noise?
Very good, actually. There is a settings in GPT Real-Time. You can configure called the echo detection. Let me see if I can show it from here. I don't think it's being sent in this configuration. It's not accessible here from the portal. But we can open it in Microsoft Learn. So there is a possibility. So there are two things. So there is something called threshold. Yeah, this is threshold. So this threshold, let me just highlight it to show. How will the voice activity detection work? So the voice activity detection, as I described earlier, you use it in order to tell when the AI should respond. And this threshold has to do with the sensitivity. So the higher the threshold, that means that you put a higher limit to accept a new voice activity. And this will work better if you have a higher noise. Okay? And vice versa. That's what we see in the portal. On this configuration here, if we go back to the session update, I can send the URL for that. There is a possibility actually in the GPT Real-Time to apply some noise cancellation and audio processing capabilities to improve it.
Threshold is for the semantic value, you mean?
Yeah.
For just now for the threshold and these values you are speaking about, is it a tool calling or is it something you define or hard code?
It's an event you send in the WebSocket. It's not a web calling. So you see the WebSocket events we've seen earlier.
Yeah.
You just send another WebSocket. I think on the session updates event itself, you can send that configuration. The one we see here, it's not used. That's why it's not sent in the payload, but it's a WebSocket event.
No, my question is it hard coded? So it's not dynamic, right? So like if the value here is 0.5, throughout the session it's going to be.
No, that's the point. So it's hard coded here in the UI, but throughout your session, if you decide that you want to change it, you will just append a new session.update event. Remember, you have that WebSocket established, and you can play with it with those events. You will just send another event saying, okay, no, I want this value for the noise cancellation or this value for the voice activity detection, and it will update.
Okay.
Does that clear? From a session perspective, it's dynamic, but if you look at it from a UI, yeah, it's static. But you have that capability as a developer to update it, not as a user.
Yeah, thank you.
Welcome. Okay. Let's begin. Okay. So now we have seen that on the playground in Microsoft Azure. I'm going to show a demo, a very small demo that I've built. We're going to interact with it to see how it works. Then we're going to look at few code snippets to see how to update those events we've seen just earlier programmatically and cover things like session configuration, events, tools calling, and so. Any question? Cool. So let me go to my Visual Studio Code. So this is sample AI assistant I built. You can chat with it, and in the chat, actually, you can. Let me just remove this. You can apply certain configurations, so you can play with the system prompt. You can control the voice, the temperature. Does anybody know what the temperature parameter is?
Oh.
Exactly, creativity. That's the short description. and things related to the VAT threshold, silence duration, and so. There are other configurations. I didn't cover everything. As I mentioned on the documentation, you'll be able to see that, but I just focused on the main ones. So let me have a look here. I have a description of this AI assistant. Yeah, and that AI assistant actually has a tool. That tool will send an SMS if I ask it to do so. Practically, it doesn't send an SMS, but it executes a function that will print it in the UI. This is an SMS has been sent. But if you want to implement that, it's simple because it's a code chunk that gets executed, and you can configure whatever sending tool to execute that. Okay. So let's start it directly. Yeah, so I don't know what would be the best way to share the output audio actually. I think if I share audio, you know what? I will share audio from here. Share sound. Hello, how are you?
I think it's listening to itself again
Okay.
because it echoes.
Yeah.
That's why it's
So then, you know what?
try without audio. And
Yeah, I will do it without audio.
Sure. All right, that sounds good. Take your time, and if you need any tips or guidance along the way, just let me know.
Hello, can you hear me?
Hi. Yes, I can hear you loud and clear. I'm Aria, your Azure AI assistant. What's on your mind today?
Can you tell me a joke?
Sure, I'd love to. Here's one for you. Why did the math book look sad? Because it had too many problems. Glad you liked it. If you want to hear another joke, chat about something else, just let me know.
can she switch languages?
Can you talk in Arabic?
بالتأكيد أستطيع التحدث بالعربية. من فضلك أخبرني بما تود أن أتحدث عنه بالتأكيد يمكنني التحدث معك بالعربية. هل تفضل لهجة عربية معينة مثل اللهجة المصرية أو الشامية؟ أنا مستعد لأي غياب تفضله.
Okay, speak Arabic Egyptian.
حاضر. هتكلم معاك بالمصري. قول لي بقى إيه اللي حابب نتكلم عنه دلوقتي؟
Okay, perfect. Can you please summarize the whole conversation and share the SMS?
تمام. أنا بعت ملخص للي اتكلمنا فيه في رسالة نصية. في أي حاجة تانية حابب نتكلم عنها؟
Sorry for the Arabic, but this is just a summary of the conversation, okay? What I'm gonna do next, I'm gonna do a small update here on this system.
This is with AI based, right?
Yeah.
You don't want it to. What's the best way to do it?
You can do that mainly through the system prompt. But this system prompt controls the AI behavior. I can add something like the guardrails will not cover that part in particular. The guardrails will cover mainly, if there is a violent speech, if there is like illegal content, those type of things. You can track it with something else called evaluations. So, but that's a different discussion for now. You can run evaluators on your AI model to make sure that it does not respond to language switching requests. But I would say the most common way to use a system prompt. So let me update this system prompt. No, it's a single model. It's the GPT real-time model. So we are not doing the speech to text LLM and that thing we described earlier. Okay. What?
Either have Cedar or Alloy or one acoustic model in the back.
Like the
The voice model. So that's very good. Maybe we can look at that in the MSDN documentation. Generally, you have two types of voices. There are OpenAI voices, around 8 voices or something, and there are Azure standard voices. This is where you can use big collection of Microsoft voices. Okay. Sorry, apologies. In GPT real time, it's only OpenAI voices, but that's something else, Voice Live API, where you can use the standard. But for GPT real time, it's only OpenAI voices. With Voice Live API, which we are not covering. Yeah, so Voice Live API is an add-on on the GPT real time.
Yeah, I think we could, for example, what if we could simply, because I have one of my team members now using AI Foundry and I give her a task to do that. But what I asked it actually, and we're creating a product for our customers. Sometimes our customer feel that they need to speak to one of our team members. So we have asked if we could record in the AI the voice of our team members and video also as well. So is this could be possible that instead of AI voice respond to you, a human?
It's like a voice cloning.
Yes.
Yeah.
It's available.
Yeah, that's possible on the Voice Live API. So in the Voice Live API, you can train a custom voice. There are certain requirements, like an actor consent and so on from Microsoft. You submit a couple of samples. We train it. We give you a model that will mimic that voice. Same thing goes to the video. When we are talking about video, then I guess you mean avatar, right?
Yes.
Yeah, avatar. Yeah, that's also possible. So there are also requirements to record the avatar, like having a green screen and so on. Once you achieve that, you'll be able to do that. Actually, have a couple of use cases implemented by Microsoft in Qatar, right? For that.
if you have WebSummit, you might have seen it. So what you're just mentioning is custom neural voice,
Yes.
Which is part of Voice Live API, which is like a layer that you can add on top of these real-time models. So basically, we did it with like one specific requirement. Like for example, a lot of these models, they don't perform well with the Qatari accent, right? Like when you ask to speak Khaliji, it speaks like Saudian, which is different from the Qatari accent. So you could get a voice model. You have to get their consent and everything. You sign a form, and then they read a list of sort of phrases, and then it will train on that model, and then you could use it as an option to customize the voice, similar to video as well.
And this is very helpful actually, because we started this project, but is there a source that we could have like a documentation for AI Foundry where?
Yeah, it's all in our docs. Just go to Microsoft.com. There's search for custom neural voice, and then you'll find it.
Yeah. Oh, we can sync after that to show you the resources. That's completely fine.
Yeah.
Okay. Welcome. Okay. So
it sent you the SMS.
I am not sending a real SMS. I'm just showing something in the web browser. Yeah. The whole idea is that you can execute a bunch of code. In that bunch of code, you can do SMS messages and so on. So you speak in English only, and you don't respond to language switching.
That you can implement these techniques in the prompt itself.
Yeah.
Ideally, you should, because you would want to customize it for your business case. Yeah.
Yes, I muted it, so you might. Yeah.
Loud and clear, my friend. You're coming through like a rock concert in a quiet library. What's on concert? Awesome. Glad we're in sync. So what's
Many tokens apologize. Now I told you there is only my
And then thinking and then
That's completely possible, I think. Other mic?
The other mic is dead.
Okay. Yeah, that's completely fine. Just remove this instruction to not to switch the language.
Yeah, earlier if we saw we was talking in English and then we asked in Arabic and he asked in Egyptian.
continuation of the context. So like I
Yeah.
start a sentence in English and then I continue it in Arabic. So is it able to understand between the whole sentence?
Yeah, so you specify that as well in the system prompt. You tell it that you continue your conversation on the context on the language which you switch to. So the system prompt is, the steering wheel you use to control the behavior. We had Johan.
Oh, yes. He's
You can
good.
go. Yeah.
So I wanted to ask, let's suppose if we have different language models, for English, let's suppose we are using Cedar, for Arabic or for Urdu, we are using some other language, let's suppose some other model, I mean, the caustic model or the language model. So
Between voice.
yes, the voice. So do you recommend switching the language then?
It would look awkward. So imagine if you are talking to someone and then suddenly their voice changes completely, right? From experience point of view, that would look awkward or will sound awkward actually. It's technically doable. You will send another session update event. But for me as a listener, that would look weird.
Okay, perfect. Thank you.
So I'll add in this against jailbreaking. I mean, considering how better people are getting at jailbreaking advanced models. I mean, Fable, which is like the best of the best, got jailbroken the very week it was released.
Very good question. And this question goes to all models, not the voice models only, right? In order to protect against that, we have the guardrails. So again, that goes to the same guardrails thing. One of the guardrails is a guardrail that protects against jailbreaks. So, and you can do what we call model eval. So we have something, now we'll get slightly security discussion. We have something in AI Foundry called AI red teaming. What does that do? It will, instantiate like a bunch of ethical hackers that will keep running those type of tests against your AI model to make sure that it doesn't get compromised or jailbroken. So we do our best to protect against those type of attacks. But as you know, I would say there is no system in the world that's perfectly protectable. But are there controls, high quality controls there in the platform? Yes, there are. Okay, we had few of hands there.
So, like you have shown the high-level architecture initially, right? So when we are talking from the web UI, request is getting routed through a WebSocket with the middle layer, right? So it keep sending the voice within second, let's say 2 seconds. So now the thing is that the response that I am getting, the response is a collective response at the end, or response is also coming in the same manner?
They are coming in the same manner. So if we look at the event, you'll find there is a stream of incoming events as well.
Okay. Now here the point is that let's say I have some, in my organization, if I have a some internal application, okay. So that application have a SQL database as well as a guidebook as a, knowledge. Okay, so what I did, I have trained my model with the guidebook. If somebody is questioning about my on my support page, somebody is questioning about my application, you should check in the guidebook. If, and so now I want to have a control on my middle layer that based on the user's question where I want to point it. It is a guidebook or it is my database. Let's say if it is saying that, okay, give me the summary of the projects which are delayed. So that means it have to go to the database. Yes, it will not be a general knowledge. So
How to manage that?
yeah, how to manage that?
Very good question, and it has to do with the LLMs in general. So the question is, if I have multiple knowledge sources, like a guidebook and the database, right? And each one of them has a certain type of data. So for example, if a user asks about, I don't know, maybe their vacation, it needs to check the guidebook. If it asks about ongoing projects, it needs to check the database. In the system prompt, one of the things we do, I don't have it here. So what you described is called tool calling. And tool calling in your context, in this example, is used to interact with the database or a guidebook. If I want my AI model to interact with those, in my system prompt, I specify to it how it should interact with us. For example, you will tell it, if a user asks about their vacation, you need to check that guidebook. And there is that function to perform that. You give it a bit of context. And then the AI model will understand that, okay, this user query based on the intent is meant to check for the vacation, which is in the guidebook. Behind the scenes, it will do that and query the right resource. We have something called Foundry IQ. Check about it. It does what I described, but in a way smarter manner. Okay, what we just described is the traditional RAG. There is another level on top of that called the agentic RAG. We do that through Foundry IQ. I highly recommend you to look at that. Okay. Perfect. So, any more questions before we go forward? Yeah.
On that topic, so as you mentioned, like, but this was a very, very specific thing that the question the customer would ask about their vacation.
Yeah.
But in general, that wouldn't be the question. There would be a lot more questions based, which would be going to the guidebook instead of the database. So how do we decide on that? Because that was a very specific question.
Yeah, yeah.
So if it's a very general query and based on that, it has to decide which one to go to. Do that.
Yeah. So as a domain expert in your organization, you know where those type of queries should go, right? Maybe you have 5, 6 type of resources. You will educate the model in the system prompt for those type of queries, go there. For those type of queries, go there. If there is something that you don't know about, there I can respond, sorry, I don't know about that. Do you want me to hand you over to a human? Okay. Anyone? Yeah.
Is there a question in the back? Who? You?
About the you mentioned earlier that if there's echo or noise, it would like isolate. If there's two different people talking to, or like if it's in between, like between a conversation, is it possible to do that? Like mediate or
That's a good question. From my experience, no, it.
Yeah. It's fine. You can answer and follow.
Okay, yeah. So the question was about if we have multiple users or multiple customers speaking simultaneously, will it be able to identify the right one, right? Or maybe the right one has a slightly higher audio. I would say no, from my experience. Generally, the best way to handle that is before the model. So you implement your audio processing layer in order to isolate that and then pass like a clearer audio to the model. So if things are so complex, from my experience, no, it will struggle, honestly speaking.
Yeah, you have a follow-up? Could you speak a bit closer to the mic?
it was just it was just if it did work for like two people. I wanted to know how it would work, like technically, if it put two events for each voice or something.
You mean if so you mean if you have multiple customers, right? With the same mic. With the same mic, yeah. So at the end of the day, whatever they say gets translated to events, right? These will be just a series of events sent together. Okay. Okay, perfect. So let's continue.
Is there a question? Okay, you can proceed.
Perfect. Let's have a look at some of the code snippets. Yeah, so we already went through this. This is the architecture that we implemented. So these are a couple of code snippets on the implementation. I always forget it.
It's all right.
As I described, we have the browser interacting with the middle layer and Azure OpenAI. What you see here, this is a snippet from the middle layer. So one of the things it does here, starting the conversation, it connects to the WebSocket endpoint. Remember when I was showing the developer tools and there was a link WSS blah, blah, blah. This is what happens here. So this SDK is implementing that connection. And if I go also forward, since that, you remember the one you have seen in the browser, it has a query string with an API key, the one that I need to rotate because I exposed it and now it's in the recording. Here, I am not using that API key authentication. API key authentication is not a best practice, by the way. So I am using something called, anyone familiar with the managed identity and managed authentication? Yeah, exactly. So I am using that here. So I need to call just certain endpoints and do some gymnastics in Azure in order to authenticate it. Code-wise, this is called Azure Default Credential. However, you can still go with the API key or with the managed identity. Okay, so that will enable the authentication part as well through something called JWT token. That on itself can be a separate session. Once I start my conversation, I can start sending the events I described earlier. So you remember we've been seeing different events being sent. For example, in the instructions, I can put the system message. That's the system prompt. I can configure the voice turn detection, configurations, threshold, prefix, all the stuff we've been discussing, seeing in the UI. You put it here. Also, there is a configuration for the modalities, the audio transcription, and the tools. So you remember I was showing the SMS sending part. SMS sending part essentially is something called a tool. That tool is just a function, so it's an actual code written there. And the AI model, when it detects that intent, it will translate it to an execution on that function. So yeah, this is this has to do with the events during the conversation. So when the response gets created, when the response gets returned, I won't deep dive into that because, and you will see that I have skipped some of the code parts. The reason is that simply what is happening on the browser side, as the user speaks from the mic, a translation needs to happen from the voice or the voice API driver from the OS to a specific event and put that event in one of those structures and send it back to the server so that the AI understands it. It's slightly complicated to implement, frankly speaking. So I would highly recommend if you want to implement that, we have very good code samples in our documentation. Just reuse those code samples because they have been tested. If you try to do it yourself, you could struggle a bit with that. Okay. The final thing is the tool calling. So again, the tool is being configured just as a function. In that function, you define what kind of arguments the function will take from the conversation context, how it should be executed. And one more thing, actually. So I was looking for this. One of the things you need to actually look at is the tool calling done event. So once the tool calling on the server side is done. Okay, let me check.
Just
how to do it in PowerPoint?
Just use your fingers, maybe you can zoom in the screen.
Okay, good to know. Yeah. So this event is important. Why? Referring to the example you've just said, so maybe you are talking with the AI so that it gives you a response from the knowledge base. What if your knowledge base is slow to respond? So it may take 3 seconds, right? Maybe you have a legacy system, and that does not make sense in a conversation experience. So what we generally do in the system prompt, we tell it that, okay, if the response from that downstream source takes time, tell the customer, wait a moment while I look for your answer. Conversationally, that makes sense, right? We are used to that. When we talk to agents, they tell us, okay, wait maybe 3 minutes. And then in your code, you will need to make sure that to capture that event if it happens, so that if you want to continue certain things on the conversation. That's why the GPT real-time also informs you about those actions. There are, as I mentioned earlier, more than 30 or 40 actually server-side and client-side events that can be tracked and executed so that you can hook into different parts of the event stream and perform certain actions.
From the tool or that would be added in the prompt?
And the prompt. Yeah, the prompt, that's the model behavior. What have I done?
Mohammed, this is using like vanilla OpenAI APIs. Is there a way to do it using the Microsoft Agent Framework as well, or is it more optimized to do OpenAI Python?
Very good question. It's possible to use it from the Foundry agent. I'm not sure, frankly speaking, about the Microsoft Agent Framework, but in the Foundry agent, you can configure this directly. Actually, it's a voice live API, and then it gets exposed for you from the Foundry agent directly. But the agent framework is mainly used to implement the agentic workflows, right? And the model itself will be something separate. So I would say you need both, just the agent framework in order to, orchestrate your agents and so on. And still you need an AI model to achieve the conversational experience. Let me share my screen again. So up to now, we have discussed why we need GPT real-time, how it works with the WebSockets, quick walkthrough in Azure portal, the demo. Now we're going to discuss how we can integrate the whole experience with the telecom ecosystem, right? So all that stuff we are discussing is happening on the IT or internet world. How can we integrate that with the telecom ecosystem? So a question here is, has anyone done something similar related to telecom protocols, working with SIP integrations? I know we IT guys rarely work with that. Okay, perfect. You work with that. Okay, interesting. So let's go.
What's use cases for something like this?
An IVR, right? So maybe you want to call an IVR of a telecom company, and instead of having a human, you will have the AI to interact.
So customer AI customer service.
Yeah.
Yes.
Field call.
Fields call.
Yeah.
That rather than cold calling by humans.
Yeah, you receive this a lot. AI calls, yes, especially from the US number, yes.
So I worked for around 1 year and a half in a company called Ericsson. I'm sure you know it. And the conclusion I reached to actually telecom is one world and IT is a completely different world. Seriously, like telecom is different even on the protocol stack level. In IT, you are talking about network OSI, they are talking about something called SS7. It's completely different world. And if you want to integrate them together, that requires a bit of engineering work. But in a nutshell, for the telecom traffic to go to the internet traffic, there is something called, so there are a few things. There is a component in telecom called IPPX. This component is pretty much responsible for, you can say, collecting your calls or creating them in a call stream. There is a component called session border controller. This component responsible for terminating your calls outside the telecom provider. However, For these two worlds to speak, the internet world and telecom world to speak, they need to have a common protocol. The common protocol they speak is called the SIP protocol. SIP stands for Session Initiation Protocol. If you heard about the voice over IP apps, they use this protocol. This protocol mainly manages two things. Well, it's called SIP just conventionally, but practically it's called SIP RTB. Why? SIP protocol is responsible for what we call the control signals. So a signal that someone is ringing, a signal that someone has closed the call, a signal that someone referred the call. With it, another protocol called RTP protocol. It's not specified here, real-time protocol. That's the protocol having the actual voice payload. And this protocol, they play together. So you always have SIP and RTP together. You will hear people saying SIP, but in practice, it's SIP RTP. SIP protocol goes over TCP because you need to have determinism. The RTP protocol goes over UDP, just like any non-deterministic protocol. Okay. In telecom, they have the capability to support converting the voice traffic to SIP. So you will hear telecom guys saying that I have a SIP trunk or I have a SIP endpoint. What does that mean? That means I can terminate the voice in a SIP URL so that you can listen to it. So the point here is that for any telecom integration to happen, you need to have the telecom side providing a SIP trunk. They have to give their voice in a SIP trunk. If they give it in the native voice format, it has a certain name, actually, I forgot it. Simply that does not work. If they had SIP bridge, it goes to the internet world, it is possible to use it. Okay, once you have received it as a SIP, there are a couple of ways to interact with it or to deal with it. So what are those three ways to deal with that voice? Either through Azure services, third-party components, or open source. Through Azure services, we have.
I'm just zooming.
Thank you. So we have a service called Azure Communication Service and Microsoft Teams. They have SIP interfaces. So you can ask whoever on the telecom to point that endpoint from their SIP trunk to your Microsoft Teams or Azure Communication Service so that you receive the voice payload from there. This is simply said and done. Like, there are a lot of complexities and challenges with the possibilities of integration between different SIP providers, but that's it on a nutshell. If you go to the second box, please. You can use third-party components. So there are some commercialized third-party components, like something called LifeKit. They implement the SIP protocol. You can you host it in your environment. You point your SIP trunk to that, and you will be able to terminate the SIP traffic. The last one. So as well, there are few open source components that you can host and be responsible for, like PageSIP and Asterisk. These are the most well-known ones. You can use it again in order to receive the SIP traffic. When you receive the SIP traffic, you will have the following architecture. If we go to the next slide. Sorry. Maybe I need to go back. Yeah. So once you receive this SIP traffic in those components, you will be able to convert it to normal audio. Once you have it as a normal audio, you will be able to stream it back to your AI and have the conversation coming from the AI back to the telecom. One final word is that, as I mentioned earlier, the GPT Real-Time natively has a SIP interface. And that's one of the things actually we are proud about in Microsoft. No other competitor has that, by the way. It's all. Yes, but it has a one caveat. It does not support private endpoint. So if you have a strict security requirement that your voice traffic cannot go over internet, that SIP interface in GPT Real-Time will not work. You will need to use something like the open source solutions and host them, or use third-party providers and host them.
So basically, agent to do that, so people can work on other things. So for me to think of this as Vodafone, I need to think about how to integrate the AI with my sort of protocol.
Precisely.
So we need something to different. What steps that?
Precisely.
Session and
Initiation protocol.
initiation.
Yeah, that's it actually for today. So start with the questions.
Yeah. First of all, do we have questions from the audience before we go to the questions from? Are you good by the way for the?
Still need 25 minutes.
25 minutes.
Cool.
Okay. So let's take in some questions from the audience.
Yeah.
Yes, Ahmed.
Yeah, I have a question regarding the models.
Here.
The models in AI Foundry. So we've in our business we focus more on financial part. So some models are focused on. So we have historical data that's recorded already in ERP. So it's easy for us to get this one. But sometimes maybe we could need some kind of forecasting for budgeting, things like that. So is there a way we can use multi-model and these models are also available? And I can see also there is a GPT. What are the models that we can use? What's the best way, for example, to select the best model? Can we use a mix? Things like that.
Okay, thank you very much and very good questions actually. So the question was, he is in the financial industry and in certain use cases you need to predict, right? So I would say always start by asking what's the type of your use case, because some use cases fit the LLM models and some use cases fit actually the regular machine learning models. I would say this type of problem would fit more on the traditional machine learning models like a classification or a regression model. You fall back to the when you use the LLMs. Number one, if you want text generation and capabilities, you want to implement an AI agent that writes your ads or an AI agent that responds to the customer service. The nature here is text generation, or the nature is reasoning. So you have a lot of reports, a lot of data. You want to analyze that data and get certain conclusions. You will find some AI models good with that. Coming to the second question is how you tell which model is better. So there is something called model leaderboard. Let me see if I can open it here quickly. Or actually, we have one leaderboard in Microsoft Foundry. Let me go here. I think I need to go to model catalog. Yeah.
Is Cloud available now in Foundry?
Yes, we have Cloud model in Microsoft Foundry. So those models generally are rated with different criterias, things related to quality, safety, throughput, and so on. This is from Microsoft. You can find for others as well, and cost as well. So you can come to this leaderboard, filter by your purpose, and then compare the models with each other, taking into the consideration your cost tolerance, of course.
Does this include those models?
Yes. Yes. So one of the things actually in Microsoft Foundry, we have more than 11,000 models, more than any provider, by the way, in the market. And of them also open source models, Hugging Face models, GPT, OSS, all those types. For example, you can see here, Kimi model, DeepSeek, these are open source models. They are here as well.
Assuming Foundry builds it in terms of tokens.
Yes.
So what are some cost mitigation strategies that we can implement? So for instance, if I'm building an agent from scratch, I have fine-grained control over context caching or context summarization. Are there any cost mitigation strategies that I can implement in Foundry?
Yes, a very good question. It's about saving cost when you have, when you have an AI use cases. I would say, firstly, like natively, we have some cost saving mechanisms called prompt caching. So if your prompt meets certain requirements, like on the beginning of the input, we can cache it and reduce the cost, I think, by 90% or something. Secondly, your system prompt. So system prompt is very critical because it gets sent with every request. So if your system prompt is big, That means for every single request, you will have a big amount of tokens to be built. So always optimize the system prompt. Usually that's a hard balance because you want to give as much details on the system prompt for the AI to behave correctly, but at the same time, you want to have at least as possible in the system prompt to save the cost. So you will need to do some, I would say, trade-off here. What else? Yeah, like we can take a full session on cost optimization. Things like compaction, context summarization, and so on. But these are some of the techniques you can use. The question?
So with the SIP in place, wouldn't that kind of like add more latency to it, as well as with a telephone call, there is always like interruptions sometimes in between. So how would the GPT model like handle that?
You mean the interruptions? You mean the latency due to the increased system prompts, or what type of?
Due to there is an protocol in between, right?
Yeah, the SIP bridging. Yes, but it's extremely minimal. So you have seen earlier that I have specified, for example, open source library called PageSIP. That library is written in C, and if you know, C is an extremely efficient programming language. The reason is that to handle that use case as in particular, to make sure that this SIP bridging does not add any latency. We have one blog post, actually, one of our like global team members, he did the exact benchmarking to see how much latency this adds, and it was less than 5 milliseconds. Yeah, less than 5 milliseconds, like the latency due to the SIP bridging. You would imagine at the beginning, actually, I thought it will be a lot, but when reviewed the benchmarks, it's not a concern at all.
So when we are connecting with the real-time API, real-time AI, right? So to get the context from like the tools, you said like we can connect to tools. So what are the type of connections available? Like we can connect through MCP or like RAG, all the systems available.
Yeah, so you saw me here like use tools. This is more from the RAG era. But right now, the standard way, the way to go with is the MCB. So you will use MCB, and your MCB then connects to any downstream.
So that connection is we can connect.
It's supported. Yeah. It is supported as well. And you receive an event for that. Actually, I'll see if we have like 5 minutes or so to go through those. Okay.
Yeah, sorry, I have a lot of questions this part.
Sure.
So we have a use case, and we're still planning for it, but I need to check also if we can do this in AI Foundry. So actually, in the ERP or data entry, we have the customers actually upload currently what they are doing is uploading the, for example, documentation like invoices, receipts, blah blah blah. But they entering the information, so we're thinking that, okay, but it's too much information and it's headache that we could manually check that. And we don't need AI to extract the data and enter this manually by AI. So we still need the human to enter the data or the invoices and just upload the attachment. But actually, we would like to have an AI that audit the entry of data. So for example, the AI extract the data from the document and compare it with the entered information. So it will be like an audit.
Like cross check, yeah.
Yes. So is this could be a model can be done with something like that here?
Very good question. Yes, we have actually services more focused towards those. So one service called Document Intelligence. This service is more suitable if your documents of predictable format. So you receive a invoice in a specific format. It will exactly do that. So you will train it on your document template. And then it will, sorry?
Is it inside Foundry or outside?
It's
another service in Azure.
It's so what we are doing recently, we are trying to consolidate all our AI services under Foundry, but practically it's behind Foundry. You should be able to see it from here. Actually, let me switch to the new Foundry view and show it quickly. It's not. Let me open it from Azure portal. That would be faster. So you see, this is the service. We have put it under Foundry as a part of the consolidation, but practically it's a separate service you create and interact with it. If your documents are not of structured and predictable format, there is another service called content understanding that do that. And behind the scenes, it uses LLMs in order to detect the content. So that use case is perfectly achievable, and have so many customers in Qatar have done that.
Yeah, so I just wanted to ask because it's the first time I come across SIP. Is SIP and webhooks compatible technologies, or are they completely different?
No, they are completely different. So SIP is a protocol to carry the voice, and webhooks is a more of a mechanism to notify of an event that happens. So you can think SIP is slightly close to WebSockets because it's synchronization. It's not like WebSockets. Webhook is request response. So if I have, for example, a system and I want to be updated about certain event, like I don't know, maybe I want to know, for example, there is a, Stripe, it's a payment provider. They expose webhooks. So if you, or sorry, you expose webhooks to them. So in your system, if you want to know that, okay, did the customer perform the payment, you will configure your webhook in Stripe, and then Stripe will call you to notify you of that event. That's a pure request response manner. It's not a session. So it serves a different purpose.
Yeah, I think why I compared them because I thought of them both as maybe they deal with triggers to then start the process. So here you mentioned, for example, this would be if someone called. So that's the trigger. Here.
Okay.
And then webhooks, if a payment happens, then notify me that this happened.
Okay, yeah, makes sense. Yeah, like the trigger could be similar, but the nature of the protocol itself, I would say it's completely different.
Architecturally, it's different, basically.
Yes. Yeah.
WebRTC, the real-time thing, something.
Which one? The webhooks?
Yeah.
No. Webhooks use request response pattern. Okay. WebRTC is more of it's similar to WebSocket, so it's not a request response. By the way, it just sends it. It uses UDP. Coming to that, actually, I see there is a lot of discussion around those type of protocols. I want to show you a very good course on this. So actually, if you want to understand these protocols really, really good, this course is exceptional. This could be the best $14 you invest in your career, honestly speaking. So it will teach you all those type of things: TCP, UDP, WebRTC, WebSockets, HTTP, when to use what, the different type of protocols, and so on. Especially if you are a developer, this is a must. And this guy in particular, Hussein Nasser, he's an architect. He's really good, actually. He has other courses in networking and in the databases. You literally understand things, from the fundamentals. So, right? Many times you work with things, you feel that, okay, you sort it works and you understand it, but what's happening, you don't know, and you just, you just asleep on it, right? It works, exactly. But if you want to understand it, like, on the wire level, watch courses for this guy. I would say it will help you in certain troubleshooting cases. So I have been in cases in my career, for example, I want to inspect a network connectivity between two things. Just because I had an understanding of the underlying protocol, I can see, okay, this protocol is not completing its journey. It's sending requests, but for some reason I'm not getting a response back. And if anyone is working in the network, guys will say, okay, yeah, no, it's working on my end. Until you have that level of troubleshooting to show those logs, you won't be able to prove that for the networking guys. It's extremely useful, yes. Okay, yeah. Any more questions before I go with my questions and gifts? Sure, go.
Right now, you gave the demo for the voice AI for like the public network, if I'm not wrong. What if like we are in a scenario where we need like everything in the private network? Do we have to like change our approach?
Yes, very good question. So yeah, the question is, what I've deployed is on a public URL. What if you want to deploy it on a protected network? I guess you mean enterprise or something like that. We have something in Azure called private endpoints and VNets. That means you can deploy your resources in an isolated environment that no one else can access, and you apply different controls and so. Microsoft Foundry supports that. That's perfectly doable. And you will see this, by the way, in all Microsoft products. So Microsoft as a company, we position ourselves as an enterprise ready. What does enterprise ready means? We know enterprises have very strict security requirements in terms of networking, authentication, and so. And always we put that in mind when we design the products. Fatih, how are we doing in time? Should we go to the questions? We have time. Okay, perfect. Yeah. But then we can continue taking questions. Yeah.
So like we can use this SIP protocol for in the private network as well. Yes.
Very good point. That SIF feature in particular in GPT Real-Time, we don't have it on the private endpoints yet. So if your use case has a strict requirement of VNet, that one won't suit you. What will suit you is to host one of those components we discussed earlier in your network, maybe in a virtual machine or a container, and then use it. But by the way, anyhow, the traffic is encrypted. So like there is authentication, there is encryption and so on. It's only the network isolation that's not there. Yeah. Yeah. So then you will need to use other approach in order to support that. Yeah. Any more questions?
You mentioned that we're using WebSockets to connect to Foundry agents, right? But does that mean that under the hood, we're still using WebRTC for Foundry's backend to connect with the GPT model?
Okay. Good question. The WebSocket connection is in particular for the GPT real-time case. With other AI models, you use the normal REST API with request response model. Okay. Does the agents behind the scene interact with WebRTC? No, generally, it depends on how you design the communication pattern. So right now, people are talking about a protocol called agent-to-agent protocol. It uses something called JSON RBC, and between that, it uses something called streamable HTTP. That's a different discussion. This guy talks about that protocol as well, but the answer is no. It doesn't use WebRTC for communication. Okay. Okay, perfect. I have few gifts.